All right, my clock says that it's 8:31 for me or 10:31 for the Eastern time, folks. So I'd like to welcome everybody to our webinar. My name is Tanner Knight. I am with Converge, and today we are going to continue our Three Pillars webinar series that we started last month. If you didn't catch that one, it's right here. You can still click on our data creation webinar here and here and catch up on that specific webinar where we introduce the concept of the three pillars and how we're breaking down these topics for this webinar series. So go ahead and check that out. Today, we're going to be talking about webinar 2, which features supercharging SOLIDWORKS with automation and integration. And with me, I have Sean Stubbe from CADSharp, who will be so gracious enough to show us some examples of how to use the SOLIDWORKS API to accomplish some custom tasks in SOLIDWORKS. So that's what we're going to be talking about today. But just for the future, next month we'll be talking about cybersecurity with Jamie Busick from Virtual Sprout, who's one of our partners as well. And beyond that, we're going to be talking about CAD data management and CAD data distribution with flatter files, and then knowing your SOLIDWORKS entitlement. Each one of those will be around this time in the month, September 10th, October 15th. So stay tuned for that, and we'll have plenty of notice for that in the future. By the way, when we do complete a webinar, we'll have a form that you can fill out to get access to our hidden playlists. So you'll be able to come here and have a hidden playlist on our Converge website that shows you this webinar. We don't make it public just because we want to make sure that the people who have access to this really need access to it. So we want to cordon that off a little bit, but you'll just be able to fill out a form and get access to that on our website once the webinar has completed. So I think that's enough housekeeping. So let's go ahead and talk about our topic, or start our topic today, which is, one second. Nope, that's not what I wanted. Nope, that's not what I wanted. Where is the slideshow? Here we go. Supercharging SOLIDWORKS with automation and integration using the SOLIDWORKS API. And this is going to be co-presented by CADSharp. And like I mentioned, Sean Stubbe from CADSharp is on right now to jump into some examples. But first, I kind of want to set this up and explain what the SOLIDWORKS API is, how you might use it, kind of set the stage for Sean to talk about some actual use cases. So this webinar is going to be exploring how the SOLIDWORKS API can transform your engineering workflows through automation and customization. So a quick webinar agenda today. We're going to welcome Sean and CADSharp, as well as have an overview of the SOLIDWORKS API and why automation matters in engineering workflows. Next, we're going to talk about how to apply the API, kind of some foundational concepts, use cases, and essential tools, which will lead into real-world examples, which are demonstrations of custom automation tools and workflow improvements. And at the end, we'll have a Q&A session. Basically, we want you to say, can you make SOLIDWORKS do this? Come with your own real-world use cases that you'd like to see if this is something that we could do. So that will be at the end. So let's welcome Sean Stubbe from CADSharp. I'll let him introduce himself in a second here. But before I let him talk, I just wanted to talk about what is the SOLIDWORKS API, because in all honesty, it's kind of an alchemy in a lot of regards. It's kind of like a hidden art in a lot of ways that not a lot of SOLIDWORKS users are aware of how to use this functionality. But with kind of a little bit of coaching, or even if you just say, can SOLIDWORKS do this, and bring it to CADSharp, they can go ahead and create you a button to actually do that. So the SOLIDWORKS API is a powerful interface that allows you to automate repetitive tasks, customize workflows to your specific needs, and integrate SOLIDWORKS with other platforms. So today we'll explore how API automation can transform engineering workflows and dramatically increase productivity. So with that, I'd like to introduce Sean. Well, Sean, why don't you introduce CADSharp and just talk a little bit about what you guys do day to day, and we'll get into this webinar.
Sure. Well, good morning, everyone. Nice to be here. Like Tanner said, my name's Sean Stubbe. I'm the General Project Manager at CADSharp. we have a few divisions. The one that concerns us today is custom software and consulting. So we write custom software to support the engineering and manufacturing world. Today we'll be focusing on the CAD side of that. So we'll work with an interface every major CAD platform, PLM platform, ERP, etc. If it's anything to do with engineering and software, we'll talk about it and write software for it if necessary.
Yeah, that's exactly right. And the software in question is typically going to be connecting to a different database or a different source and utilizing applications outside of the SolidWorks infrastructure in a lot of cases. Is that safe to assume, Sean?
That's correct. Yes.
And there's a lot to do inside of the SolidWorks infrastructure, and we'll get to that. But that's the topic of today. And basically, at the end of this webinar, I want you to think about some things, how you might be able to gain some productivity with your team through use of the SolidWorks API, programming some things to make their lives easier. So, who benefits from the SolidWorks API? Well, engineers do. They automate repetitive design tasks. You can create custom tools for specific design challenges. These are design tools that don't exist in SolidWorks. Keep in mind. It allows you to also streamline workflows to focus on innovation rather than routine operations. Who else benefits? Well, CAD administrators. They manage large assemblies, or it helps them manage large assemblies more efficiently. That helps them implement company standards automatically and create tools that ensure design consistency across teams. So the folks who are administering the SolidWorks infrastructure and workflow, the SolidWorks API can certainly help them out day to day. And finally, we have system integrators. These are the folks outside of the SolidWorks ecosystem. You can connect SolidWorks with other business systems like an ERP system or PLM system to create custom data flows like pushing a bomb over to an ERP or something like that. And you can build specialized applications for unique business needs. So that's who will benefit from the API. Well, guess what? That's pretty much everybody. So that's the point here, is that the SolidWorks API has benefits for everybody in any engineering organization. Some practical use cases for the API. We'll see these in action when Sean gets into his demo here, but we have automated part and drawing generation. Go ahead and create hundreds of similar parts or drawings with parameter variations in seconds instead of hours of manual work. So basically create a button that creates hundreds of whatever you need. We also have bulk file property updates. SolidWorks files are very heavy with metadata, and all of that metadata can be changed without even opening up SolidWorks, which is really great. Using bulk file property updates, you can update metadata of all SolidWorks files in whatever data set you want. You can update revision information, custom properties across the entire folder with just a single click. So that's really nice automation if you do end up needing to change mass properties or metadata in SolidWorks kind of en masse. The next use case, as I mentioned, system integrations like PLM or ERP, or any other software system. You can get an interface that works directly from SolidWorks, translating data into that secondary ecosystem. Design rule checking, automatically validate designs against manufacturing requirements. If you have DFM requirements that you need to hit, then we can run a batch validation script to ensure quality. So you'll see a lot of common threads here. We're trying to do batch actions and things that are very repetitive. That's what the API excels at knocking out tasks for. So real world examples, API in action. This is where Sean's going to take over, but we've got some real world examples, some custom automation tools, some workflow improvements, and I'll hand things over to Sean now. We'll include automation of drawing packages and some PD options and ERP-friendly exports as a little preview of what we're about to see. So I'm going to stop sharing and give the reins over to Sean. And we should be seeing his SolidWorks very shortly. All right, we're good to go.
All right, so like we said, this is going to be focused on SolidWorks. So I'd like to start just by demonstrating what we can do in SolidWorks with the API, and then we'll look at what we can do outside of SolidWorks because we can use the API outside of it. And we'll talk a little bit about PDM as well, because chances are if you're using SolidWorks and you develop a product, you're probably using PDM, which also has an API. So there's some aspects there to discuss. So inside of SolidWorks, what you can see is obviously anything we change in the user interface. So we do that via add-ins. So just loading up the add-ins menu here, you get some default ones with SolidWorks depending on your license level. And then third-party ones or custom ones show up here. So you can see I've loaded a demo add-in here called the CADSharp SolidWorks add-in. And we distribute these via an MSI. So a Microsoft installer package, pretty standard. For larger add-ins or integrations, we can also implement automatic updates. But for smaller ones, you just get a new MSI and run it to automatically update the one in SolidWorks. So once you have an add-in installed, we can do a few things with that. So first thing is it usually shows up in your tools menu. If you ever get an add-in from us, it will show up here. And we add commands. So you're always going to get a simple about command that just says what the add-in does, the version. If there's automatic update functionality, it'll be implemented here. Note that that launches a custom window. So we can put anything we want in these windows and add functionality there. A good example of that is typically you'll have a settings window with settings that apply to the add-in specifically. So here's, again, this is all demo data, but here's an example of one. A few different settings you might want to have in a SolidWorks add-in. I should also mention that all of these use cases are going to be very simple. So we can make these as big or complex as necessary. But for sake of demonstration, we're going to keep it really simple. So that's the first part. We can add simple commands. Those are actually real SolidWorks commands, meaning they show up in your user interface customization options, and you can move them around as you see fit. By default, we'll usually add a couple toolbars. In this case, I've got a simple one here with some simple commands you can see. But like I said, you can move those around and create your own toolbars. I'll demonstrate a couple of those now. So a use case we do a lot of is drawing automation. This can be very simple or very complex. So I've prepared, like I said, a very simple example here. If I click this create drawing button, it's going to create a drawing of the active part. So let's demonstrate that. You can see how quick that was. That's a simple part. We just created 3 very simple views and insert a few simple dimensions. That's not hard coded. That would work for any simple part. But obviously, the more complex your geometry is, the more complex the dimensioning is going to be. So that scales quite a bit. So yeah, there's a simple drawing. Like I said, we do this a lot for repetitive parts where, especially sheet metal, if you're making a lot of similar parts and need to pump out a lot of drawings, PDFs, DXFs, it's a good use case for automation because that's taking up a lot of your designer's time, and there's usually not too much thinking involved. And there's always a human review step, right? So you don't have to fully trust it. The designer has this command, he clicks it, reviews it, makes any necessary edits, and he's still responsible for the accuracy at the end of the day. So that's a simple use case. Another more advanced one I've got here. So if I click this command here, we get what we call a property manager page here. So this is a custom feature, but it's built to look like native SolidWorks. And we build these when we need a lot of model selections. So in this case, I'm applying a feature to an assembly that you can't do normally. So I'm going to split this, and this is made up of 3 parts. I've got 2 cylinders here of a large diameter. This part's duplicated. And then the middle one is just another cylinder with a smaller diameter. So I'd like to pattern cut that, which you can't do, well, in this manner anyways, by default. So I want some selection. So I want the start plane. So note that this plane is at one end. I want an end plane, so this plane's at another end. And then if we wanted to respect some middle planes as well, I could add those. In this case, that won't be necessary. So let's say I want to split this every 6 inches. So I'm going to hit go there, and that's going to basically add a plane every 6 inches automatically, and then cut at each plane, and then propagate that to each of the parts. So just to prove that, if I go to this part and open it, we can see those planes propagated, and we have the solid bodies. So we just took a assembly level cut and propagated that to the parts. Um, this is just an example to show what we can do. We can manipulate geometry via these property manager pages. But a real use case for something like this is calculating mass properties across a section. So if you had a complex shape like this and you need to do some analysis, you could then section that and then calculate mass properties for each body and then plot them. Um,
And just for like argument's sake, to do this in a very traditional manner would take a lot longer because you have to basically set every single plane where you want it, initiate a cut at the plane, and make sure that all of your bodies stay where they needed to be. So doing this manually would be a lot more time consuming. Just wanted to bring that up.
that's right. Yeah. And the reason I do it with this interface, like I said, is for the selections so that we don't always use property manager pages. I could implement something like this with just, I could throw a window up there and you pick a bunch or pre-select a bunch of things. But when we need a lot of native SOLIDWORKS selections, we'll implement it with one of these. We can also use these to build what are called macro features. So if there's a feature in another CAD system, like for example, cut extrude, what SOLIDWORKS does have, but let's pretend it didn't, we could build that for you. So if there's a combination of CAD operations, especially complex surfacing, where you're having to input, I don't know, 10, 12 features, and you would like to just do that with one input box, we can do that. Those do get complex, but they make sense in some cases. So custom commands, property manager pages like so. The next big one we do a lot of is we can add custom side panes. So these do a lot. This interface is fully custom. I've built one here, a very simple ERP integration one just for demo's sake. But we use these to integrate with lots of third-party systems. If you have a complex command suite, if you're doing full geometry automation, sometimes we'll build a very large toolbar up here with 20 different commands. That's a step-by-step process to automate the assembly creation or complex parts. In other cases where there's a lot of business logic and a lot of decisions to be made along that process, we'll build you a user interface in here. And then, like I said, I'm going to keep coming back to this, but that's completely custom. So anything you can imagine, we can put in here. This is essentially a separate program running inside of SOLIDWORKS. So for this demo, we're just going to connect to an ERP that doesn't exist. Like I said, this is all demo data. ERP integrations, you're typically synchronizing BOM data. So in this case, we'll show a BOM here from a fictional assembly. We could fetch parts from SOLIDWORKS and or the ERP and synchronize them. And then typically you'd have some kind of process where you would want to go ahead and synchronize said part, send it to the ERP. When we do this, we typically highlight the differences between the data too. So if typically your CAD is going to be one revision ahead of what's in your ERP until it gets released, and then we'll show the differences and you can decide what to do with that. So simple demo there, but like I said, this can be whatever you need it to be. Larger integrations typically take place in a custom task pane like this. One more thing inside of SOLIDWORKS is we can add context commands or right click. So if I right click this face here, I've got a context menu here called CADSharp ERP. Now again, these commands can be whatever you need them to be. They can manipulate geometry. In this case, I'm demonstrating an ERP integration use case, so I have some ERP specific commands here. The use case for these commands is context, right? So I know what was right clicked, in this case, that face. So just to prove that, let's say there's an issue with this that I want to create in my change tracking system. So it knows, in this case, I just show a dialog box to prove that we know what the selection is. In this case, it's selected face. Because I now have that object, I know which part that face belongs to and which assembly that part is contained in. So that's full context, and we can get custom properties from the part if we needed to at that point and create the issue in the ERP. So in terms of user interface, that's what we can do inside of SolidWorks. So we can add buttons, custom task panes, custom features with property managers, and then the functionality is limited to your imagination, budget, and use case. Um, Pretty much everything you can do in SolidWorks manually can be done programmatically. So if you can define the logic on paper, especially the business logic, we can write code that makes that happen automatically. So, like Tanner said, anything that you're doing a lot, repetitive actions or complex actions that take too long, there's a good use cases for automation. So, simple ROI analysis, right? If my designers are spending 2 hours a day on this particular task and it's always the same set of business logic, well, there's pretty good use or pretty good business case there to automate it. And that's what we do. So, like I said, that's what we can do inside of SolidWorks. There are a lot of use cases for the API outside of SolidWorks. So I've got a simple demonstration app here. This is a Windows application. We build and distribute these in the same manner via MSI, a Microsoft installer package. And if necessary, we can support automatic updates. So this is just a simple demo app to spark your imagination a little bit. I have a few different windows to show here. Typically, we do this for batch automation. So if you need to process many SolidWorks files, we would prefer to handle that from a Windows process that launches SolidWorks, opens files, and closes SolidWorks. That's so we can handle cases where SolidWorks crashes. And when realistically, if you're processing thousands of files, you will encounter a hangup at some point. So if we do that inside of SolidWorks via an add-in, we can't handle the use case where an error comes up inside of SolidWorks, a file fails to open, et cetera, et cetera. So these apps, they control SolidWorks externally. And if SolidWorks crashes, they simply log it and then try again or move on to the next file. So we can add logic to handle that. For use cases where you're processing more than 1,000 files, so tens, hundreds of thousands, or even millions in some cases, we can parallelize that. So we can launch 4 instances of SolidWorks as long as the computer has enough memory and processing power to support that and process 4 files at once or more. So that's what a standalone outside of SolidWorks lets you do. So a few examples. This is a very simple processor. Again, these interfaces can get as complex or as simple as you need them to be. But we do a lot of this where we bulk process SolidWorks files. Typically, we start with some kind of input, like an Excel spreadsheet that just has a list of files. A good example could be a custom property updater where you have column A in your Excel spreadsheet is file path, and columns B through K are custom properties with values that need to be updated. That's a simple one. So in that case, you'd specify that. A lot of times we'd have an output folder for logs, or if you're updating files and spitting out other files, you dump them in an output folder. Then you'd simply hit start, and this log here would tell you what it's doing. Progress bar would update, give you an ETA, and it would chew through those files. So again, a lot easier than opening a file, editing it, closing it manually. You can run these overnight. So that's a very simple one. This is typically what they look like. These are all custom though, so they would look exactly what you need them to be. I'll demonstrate a couple more interfaces like that. So one of them we do a lot of is drawings. So for example, this is just another demo use case. Let's say I wanted to get all the drawings created between date A and date B and add some data to them and print them. So for example, I could be editing the title block and sending them all to PDFs. So the way this would work is we'd probably have a PDM vault behind it in this case, where when you hit get drawings, it would go find all the drawings within those parameters and then populate this data grid with them, where you could add, edit, remove them before hitting print. So another simple use case. A little more advanced one. So a lot of companies that are running SolidWorks and PDM, there's a size of company there that won't have a PLM or an ERP with change management functionality. So their change management, revision 0 to 1 control, is done informally via email. There's a size of company there where, yeah, like I said, it's all done informally. So something we do a fair bit in those cases is we add functionality to PDM. Something like this, where you have an EC number. So that could be an engineering change, ECR, ECO, ECN. There's a lot of different jargon associated with engineering change management. Well, let's say I've got engineering change 6 and I want to get all the drawings with that and publish them because it's been approved. So you punch in an EC number, we hit get drawings. This then goes to the vault, finds all the drawings with a PDM data card value of that, populates this data grid with them. You fill out a few more fields here, select the drawings you want, and then hit publish. It then opens all those drawings, adds perhaps a watermark if this is a release or a pre-release for review. We could update the title block. We could stamp any necessary details here, for example, a job number, a revision, codes, etc., and then save those out into a single PDF, all as separate PDFs, and put them in an output folder. So we do a fair bit of this as well. Just another slightly more complex use case, although this is still a fairly simple user interface. Something else we do with these I want to mention is full geometry automation. So I don't have a good example to show you here, but if you have a product you develop that's configurable and you need a model for manufacturing for every order, what we'll do is we'll give you an interface here where you pick all the necessary parameters. Let's say a tank. So you pick diameter, height, gaps between panels, nozzles, how you treat the top, how you treat the bottom, and then it generates the full model. So you hit go, it opens SOLIDWORKS, generates all the parts, builds an assembly, mates all the parts, generates drawings, dimensions them, and spits out a neat little package that you can then send down to your manufacturing or shop floor to generate the actual physical parts. So that only works if you have a fairly consistent product that's configured to order and the dimensions are custom. But like I said, we do a lot of that, and those apps are really powerful. I had hoped to demo some real ones, but all the companies that we've built them for consider them a competitive advantage for good reason. So, and that applies to pretty much everything we do. So unfortunately, I can't demonstrate any real customer application because it's all intellectual property. All right, one more example I have for you. This one's worth paying attention to. I want to talk about the Document Manager API. So this is a separate API provided by SOLIDWORKS. You need a key for it. It's a company-specific key. It's free as long as you have an active subscription of SOLIDWORKS. So if that's the case, there's a form you have to fill out and send to SOLIDWORKS. And if you have an active subscription, I've never seen one to get declined, and then they send you the key. That key allows me, again, we have an internal one for development, but for use, you need your own, to read SOLIDWORKS files and write to some extent without opening. So the big bottleneck in automation or doing it manually is often opening the file, rebuilding it. The making changes part goes pretty quick, and then rebuilding it and closing it again. So if you've opened a large SOLIDWORKS file before, I'm sure you're familiar with how long it can take. And even if it's only taken a few seconds, if you multiply that few seconds by 10,000 files they need to process, well, you're into hours and even days in some cases. So that's where the Document Manager API comes in. Like I said, it can read and write to SOLIDWORKS files without opening them. So it gives us an interface basically directly to the file itself. Now it's limited. We can't edit features. The primary use case for this is metadata. So custom properties, configurations. It is possible to read and write geometry via tessellation data, but that's very difficult and very complex. So we only do that. It's a very, very large project that can take years. So typically, tier 1 customers, very, very large ones, will do that. But the use case that everybody does is custom properties. So I can demonstrate that now. This is worth demonstrating. So I just prepared a simple assembly here. I'm just going to specify it here in this input box, and I'm going to hit get properties. And these are the custom properties in that file. I can edit those and write them back without opening the file. Now, if I had to open that file, that would have taken minimum 5 seconds by the time I opened it, evaluated, rebuilt, or read them out. Whereas this was instant. So it's a factor of something like 1,000 in terms of speed. So we always look at if it can be done this way. That's about all I wanted to show in terms of SolidWorks. I think we have a little bit of time, so I will talk about PDM a little bit here. And Tanner, feel free to interrupt me if I'm going a little bit too far off topic.
So far, so
Um,
good.
so like I said, we integrate with PDM as well. I don't have a demo ad in here, but I will talk through what can be done. So we can add, it's similar to SolidWorks. We can add commands to these menus here. We can add commands to the context, so the right click, and then we can add custom tabs here. So when we do an ERP integration for a company that uses SolidWorks and PDM, there's always a discussion if you should put the user interface inside of SolidWorks like this or in PDM here. Both work. There's pros and cons to both. So like I said, it's a discussion and it usually comes down to the culture and workflow in that specific company. We do have a preference, but like I said, it comes down to company specifics. So the interface in here, just like in the SolidWorks task pane, can be fully custom. It's context sensitive, so it knows which file or files are selected. So ERP integrations are pretty powerful here. A lot of things we do in PDM are actually via task add-ins. So I should explain, this is the PDM administration interface for those that aren't familiar. We distribute custom functionality in most cases via add-ins, which you load in here. We can also use the PDM API externally. So I referenced that a little when in this demonstration app. So for example here, something like this would probably have a settings interface where you would specify which PDM vault to use, and then it will log in with the active user, and we can read and write values to the database. So that's a standalone app that uses the PDM API, but add-ins themselves can modify PDM's functionality directly. So something we do a lot is called a task add-in. If you're a PDM administrator, you're probably familiar with the SolidWorks task add-in that allows you to create tasks to publish a drawing to a PDF, for an example, as part of a workflow. We can create custom tasks that can do pretty much anything. So if you want to publish to a file type that's not supported, you want to export data automatically to a ERP whenever a file is released, you want to run some design for manufacturing checks, etc., as part of your workflow, we can create a task add-in that does that. I actually do have an example here. So this is one that we sell. It's a very simple one. So once that's loaded in, the way it functions is you go here, you create new task, you select your task add-in. So this is all default PDM so far. And then I'm selecting a custom add-in here. And most of this is default PDM, but we can add custom interfaces here. So this is custom. We can add as many tabs here as are necessary. And this will be, custom settings for this add-in. So this one, in this case, it's you specify a macro to run against SolidWorks files. So we developed this quite a few times for different companies and then turned it into a product so we could just distribute it. This is part of the SolidWorks partner program, so we can distribute it in that manner. But yeah, you just specify your file path, module, and procedure, and this demonstrates what a module and a procedure is as a macro. The use case for this is if you have a macro, you end up running a lot on your SolidWorks files already, and you want to just make it part of your release workflow, this lets you do that. So you specify the macro, and then you can either run it as a context menu, a task, you can run it via scheduling. There's a few different options there. So again, this interface here is custom. We can add as many tabs with as many settings as you need for a custom task to run. One other thing we do a lot of with PDM add-ins is something called hooks. Hooks are events that happen in SolidWorks PDM. So for example, when a file gets checked in or when a file gets transitioned, we can intercept that event and add custom functionality. So some example use cases for that, let's say the functionality in PDM for a transition condition can't quite accommodate your workflow. So you can't quite get the business logic in here that you want to. We can then intercept that event, implement any business logic you want. It's literally limited to your imagination. Show a window that says, hey, this file has this many issues with it, or it doesn't meet these workflow requirements. You can't transition it, and then stop the transition. Or we could put some options in there for the user to fix whatever's wrong automatically and continue with the transition. Um, Oftentimes on the check-in event, we'll take that file and automatically publish it or read the updated BOM and send it somewhere else so that a third-party system has live data or as live as you can realistically get. So yeah, we can modify the way PDM works to quite an extent. And a lot of companies turn to this when they've pretty much reached the limits of PDM Professional and they're looking for a bigger system, a PLM, but the budget's not there quite yet, or you can't quite justify moving to a new system. So that's where basically enhancing PDM provides a lot of value. We can give you another 5 to 10 years with PDM by adding PLM functionality to it. API is pretty powerful. I think that's pretty much everything I wanted to demo. I should mention as well that the API is only available in PDM Professional. There are some things we can do with PDM Standard. For example, PDM is based on a SQL database behind it. We are very familiar with that schema, so we can read that. So that's one workaround. If you want to get data out of PDM Standard, we can. Just writing back is where you technically need the API. But if you want to get a BOM from PDM and push it somewhere, we can do that in Standard via the database.
Yeah, that's
I
a
think
really
that's
important thing to mention because we do have a lot of folks who utilize PDM standard. And, I mentioned this to you earlier, but we see PDM standard as kind of the gateway drug to PDM professional. And if you don't have a need for ERP connectivity or API programming or 10 or more users in your PDM infrastructure, then PDM standard is a perfectly viable option. And it's good to know that we do have some API read access within that SOLIDWORKS PDM standard vault. But if you want to get real fancy with the commands, then you're going to have to go with the Pro version. So just keep that in mind. Okay, let's get back into the presentation here. So that's the extent of what we wanted to present to you today. This is just the tip of the iceberg with the SOLIDWORKS API. It's capable of so much, and it's the kind of thing where I don't recommend you go and watch a bunch of YouTube's videos and figure out how to do it yourself. Don't do that. You're just gonna go down some rabbit holes that take you in the wrong direction. That's where CADSharp comes in. They are experts at this, and they can scope a project, deliver a project, and make it very seamless and painless with regards to time frame and cost and everything versus you just going down a YouTube rabbit hole and trying to figure this out on its own. I don't want to get too deep into the programming language, but Sean, would you mind just mentioning the programming languages that you guys utilize when programming these API tools?
sure. So they're .NET APIs, which means Visual Basic or C Sharp. C Sharp is the more capable language, so that's what we use by default. You can use Visual Basic, and we will on demand, but like I said, C Sharp. SolidWorks does have a C++ API too. Again, that's getting into the weeds a little. C Sharp is the short answer.
If you do have any questions that did not get answered, then this slide will address those. So please feel free to reach out to me. I'm Tanner Knight at Converge, the director of marketing here. There's my email, tanner.knight@converge.design. If you want to make connection directly with Sean and CADSharp, his contact is in the middle, sean@cadsharp.com. So, feel free to reach out to Sean if you have any specific questions, or if you'd like to coordinate with me as your reseller to do that, I'd be happy to do that. Again, some resources here. CADSharp's website is pretty simple, www.cadsharp.com. Here is Converge's website as well, a little different with the .design, but we encourage you to check out all of the information that we have posted under our partners page. There's our whole listing about CADSharp and how we partner with them to provide you guys with API programming services that are easy to understand and easy to quote and easy to implement. So with that, join us next month as we explore the topic of cybersecurity for engineering and manufacturing firms. That's going to be a departure, but something that's really, really important to us and our clients. So Sean, thank you for joining and presenting. That was really helpful and great to see the API in action. And if we have any specific questions, I'll send them your way.
Thanks for having me.
Absolutely. And everyone else, thank you for joining. And again, you can catch this webinar on demand from our website, from that webinar page that I showed earlier. So if you do want to capture this content again, it will be available for you. So thank you, and I will see you on the next one.